Hello everyone, welcome back to my YouTube channel. My name is Srishti. I'm in my fourth semester studying in Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering. Today I bring forth a video on the subject Discrete Mathematical Structures. Let's learn more about it. I'm going to teach on the topic Fundamentals of Logic. The first one is Basic Connectives and Truth Tables. What are truth tables and basic connectives? Connectives are and or not and include even implies and if. So let's learn and. This connective is true if and only if both operands are true. For example, it is raining and it is cold. It is true only if both conditions are true. You can see the truth table of and true, 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 false, 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 true, true, and false, false, false. The next one is or. This connector is true if at least one of the operand is true. For example, it is raining or it is cold. It is true if either condition is true or both. Here there are two inputs P and Q and P or Q, which is the result. True, 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 false will also become true because it's either one should be true, false, true, true, and false, false, false. Now let's learn not and implies. Not. This connective negates the truth value of the operand. That is, it gives the opposite of what the input is given. For example, not raining is true if it is not raining. Input A, output Y, 0, 1, 1, 0. This is the truth table of not. Implies. This connective represents a conditional statement which is true unless a true statement implies a false one. For example, if it rains A, then the ground will be wet. B is true unless it rains and the ground is not wet. This is a truth table. As you can see, it is true only unless a true statement implies a false. That is, only if a true is accompanied by a false, it is false. Other than that, everything else is true. If. This stands for if and only if and is true when both operands are either true or false. For example, it rains if the ground is wet, means both conditions must have the same truth. Here, if the values of both inputs are true or false, then the output is true. If either one is false or either one is true, then the output is false, as you can see in this truth table given here. Going on to the next topic, logical equivalence, the laws of logic. Here we'll learn totally 12 laws of logic, but in this video we'll learn only a few of them. The first one being identity law. A and true equal to A. And statement or and logical gate is represented by this symbol and or is represented by this symbol. And is also known as conjunction and or is also known as disjunction. So the first one is identity laws. A and true is equivalent to A. The conjunction of any statement with the true is the statement itself. A or false is equal to A. The disjunction of any statement with the false is the statement itself. Domination law. A or true equal to true. The disjunction of any statement with true is true itself. A and false equal to false. The conjunction of any statement with false is always false. Let's move. Idempotent law and double negation. Idempotent law. A or A equal to A. A statement or with itself is a statement. A and A is equivalent to A. A statement and with itself is the statement. Double negation. Negation of negation A equal to A. Negating a statement twice returns the original value. Fifth one is De Morgan's law. A and B is equivalent to negation of A or negation of B. The negation of a conjunction is the disjunction of the negation. A or B is equivalent to negation of A and negation of B. The negation of a disjunction is the conjunction of the negations. Distributive law. A and of B or C equal to A and B or A of C and distributes over or. A or B and C equal to A and B or A of C or distributes over and. Logical implications or rules of inference. This is our next topic. The rules of inference include modus ponens and modus tollens. If A of A and A are true, then B must be true. If it rains, that is A, then the ground will be wet B. It is raining, therefore the ground is wet. Modus tollens include if A belongs to B or A implies B and negation of B are true, then negation of A must be true. If it rains, then the ground will be wet. The ground is not wet, therefore it is not raining. This is modus tollens. Now let's move on to the next one, that is hypothetical syllogism and simplification. If P implies Q and Q implies R are true, then P implies R is true. If I study hard and if I get an A, then if I study hard, I will get an A. If A or B or A or B is if A and B or A and B is true, then A is true. It is raining and it is cold, therefore it is raining. Next, we use the use of quantifiers. Universal quantifier. It means for all or for every. For all, P of x means P of x is true for all x. If P of x is true for all x, then for all x, P of x is true. Next one is existential quantifier. There exists or there is at least one. The meaning is there exists or there is at least one. There exists x, P of x means there exists an x such that P of x is true. If at least one P of x is true, then there exists P of x is true. Next one are definitions and proof of theorems. Definitions. Necessary conditions. A is necessary for B if B implies A. Having keys is necessary for driving a car. If you are driving a car, you must have keys. Sufficient conditions. A is sufficient for B if A of B. A implies B. Being a dog is sufficient for being an animal. If something is a dog, then it is an animal. Next one are proof techniques. Direct proof. Assume A and prove B. To prove if n is an even integer, then n to the power 2 is even. Assume n is even, that is n is equals to 2k n for some integer, and show 2 is equals to 4 to the power 2 is even. This is how you assume it. Proof by contradiction. Assume negation of B and derive a contradiction. To prove if root of 2 is rational, then there exist integers A and B such that A divided B by B to the power 2 equal to 2. Assume root of 2 is rational and derive a contradiction to show root of 2 is irrational. Example theorem. If n is an even integer, then n to the power 2 is even. Direct proof. Assume n is an even integer, then n is equals to 2k for some integer. N to the power 2 is equal to 2k to the power 2 and 4k to the power 2 and 2 to the power 2 of 2k to the power 2, which is even, and so on. Thank you so much for watching this video. I hope you liked it. Please do like, share and subscribe.